All right, the problem we are looking at is using a definite integral to find an area between the x-axis and a curve. The curve here is given as the function 4e to the x minus 1. In order to find that area, we're going to need to see what this graph looks like because it says we're looking at the area between the x-axis and that curve. So you probably want to sketch this out. You can use your graphing calculator, get a pretty decent picture drawn, and you'll see it's got that nice exponential curve that we're used to seeing. And you'll notice that there is an area between the curve and the x-axis below the x-axis, and then this area above the x-axis and the curve. And so I've labeled these regions A and region B. What you want to be able to do is determine what your bounds are going to be for your definite integral. And so I know that we are looking between -4 and 5, but what I'm seeing is that this region that's below the x-axis goes from -4 to wherever we cross the x-axis. And so I need to first determine what that point is. We know that our y value is going to be 0 when we cross the x-axis, so we're looking to set y equal to 0 and solve for x. And so you'll notice I've added 1 to both sides, so you get 1 equals 4 times e to the x. You're trying to isolate x, so you divide both sides by 4, so you have 1/4 equals e to the x. Then in order to solve for x when it's in the exponent here, you're going to take the natural log of both sides. So we have natural log of 1/4 equals natural log of e to the x. Using our properties of logs, specifically the power property, we can move that x to the front of natural log. It becomes that natural log of 1/4 is equal to x times natural log of e. Well, natural log of e, of course, is just 1. So you end up solving that x is equal to natural log of 1/4. So if you were to plot this point, you would label it as natural log of 1/4 comma 0, which seems strange, but if you stop and think about what that actually means, you're saying e to what power would give you back 1/4, right? That's what this is really saying. And so e is approximately, I think, 2.72, and so you're saying 2.72 approximately raised to what power would give you back this 1/4. And so it makes sense that this is actually a negative number. So go ahead and type in natural log of 1/4, and you're going to see that it's about -1.39, I guess we can say. So again, this is actually where we're determining how we're going to set up our definite integral. So our first integral to get region A, which is below the x-axis, we're going to have to take the absolute value of that, aren't we? Because this is under the x-axis. So we've got -4 to natural log of 1/4, that point here, and I hope you're able to see my mouse. You may not be able to do so. But you've got where we're crossing the x-axis, and so maybe if I even zoom it in, so I've got -4 all the way to natural log of 1/4. That's going to be my first region that I'm going to take the absolute value because I'm looking for an area here. And then I'm going to add region B. Well, region B is going to be the area above the x-axis, and so that's going to start at natural log of 1/4, and then we're looking all the way to where x is 5. And so you would find, of course, what these values are and add them together to get the total area.